So in this unit, we're going to take a look at sets, and then we'll eventually get to some inequalities. If you've ever been to a concert and you've heard the singer say, "We've got a great set that we want to play for you." When he says that set, he's talking about the list of songs that they're going to play that night. So we need to go through a lot of different types of sets in math. And these all have to do with the types of numbers or the sets of numbers. So the first set of numbers is the natural numbers. These are all of the positive numbers that are not fractions and are not decimals. So the set of natural numbers is 1, 2, 3, 4, 5, 6, 7, 8, and so on. Following the natural numbers, you have the whole numbers. The whole numbers are all of the natural numbers, and then we also tack on 0. So there's only one difference between the natural numbers and the whole numbers, and that's 0. Then following the whole numbers, we have integers. And notice that the integers is represented with a Z, has to do with German. Don't ask me, I don't know. But the integers are going to be all of the negatives and 0 and all of the positives that, again, are not fractions or decimals or anything like that. So everything counting forwards to -5, -4, -3, -2, on to 0, 1, 2, 3, 4, 5, and so on. Our next set, represented by a P, is rational numbers. Again, don't ask me why it's a P. It's just the rational numbers. Now, rational numbers are defined as all of the fractions and terminating decimals. You know what a fraction is at this point, but a terminating decimal, you may not know what it is. So a terminating decimal is simply a decimal that comes to an end. So if we said 1/4, then we know that that as a decimal is 0.25. It stops at 5. Whereas if I said 1/3, we get 0.3333 repeating. That's not a terminating decimal. That's a repeating decimal. So that's not going to be included with our set of rationals. That's actually going to be included in our next set, which is the irrationals, and that is symbolized by a Q. So the irrationals include pi, the square root of 3, and then all non-terminating decimals, like I said, with 0.3333 repeating. Following the set of irrational numbers, you have the set of all the real numbers. Now, the set of all the real numbers is pretty easy because it's all of the sets we just talked about. So all of the sets of real numbers are natural numbers, whole numbers, integers, rationals, and irrationals. They all get lumped into one set. Then there's a set that's not real. What's the opposite of real? Imaginary. And imaginary numbers include the square root of -x, the fourth root of -x, and things like that. But you're not really going to have to worry about this year. You'll end up looking at that in Algebra 2. When we build sets, we can do it in one of two ways. We can do it in set builder notation, which I'm not going to ask you to do a whole lot of. You do need to know what it is, but we'll get to that in a little bit. And then there's also roster form. And roster form is definitely the more important of the two. Now, if you've ever looked at a team's roster, like a soccer team's or a football team's roster, you're going to see all of the numbers, and then you're going to see all the players on it. So the roster is just the list of players. Well, in roster form in math is just a list of all of the elements of the set. So there's a very particular way that we build roster form. The first thing that you always have in roster form is a capital letter, and that's going to be the name of the set. Then right after the capital letter, there's going to be an equal sign. Then directly after the equal sign, there's going to be an open brace. Once you have the open brace, that's when you're going to start building out your set. So in this case, what I've done is I've included the 3 largest countries in North America, which are Canada, the United States, and Mexico. Once I've got my 3 countries, the 3 largest countries in North America, I'm done with my set. So I'm going to close it with a closed brace. So now that we've looked at roster form, we're going to take that and we're going to start using it to build some sets. We're also going to throw in set builder notation just so you can see what it is and so you can use it when you're asked for it. So the question is, How do you write T as the set of natural numbers that are less than 6 in roster form and in set builder notation? So what I'm going to do is I'm going to go ahead and take that phrase that they gave us, and I'm just going to rewrite it. T is the set of natural numbers that are less than 6. So we're going to do a lot of what we did in the first unit, which is translate the English to math. Let's start, though, with the natural numbers. What are the natural numbers again? Natural numbers are all of the positives that are not decimals, that are not fractions. So 1, 2, 3, 4, 5, 6, 7, 8. Which of those natural numbers are less than 6? Now, it's important here. Less than, not less than or equal to. So we need everything that's less than 6. So that's 1, 2, 3, 4, and 5. Now we're going to start setting up our format for our set. Now, go back to the phrase that they gave you. T is the set of natural numbers. So we're going to start with that T. Drop down your T. Remember that is means equals, and then open brace, okay? Once we've got that set up, we can then start building out the roster. So T equals open brace, 1, 2, 3, 4, 5. That's the end of our roster, close brace, and we're done. That's the solution in roster form. Now we're gonna build it in set builder notation. And set builder notation, just like roster form, has a template that you have to follow every single time. So since the name of our set is T, we're going to start with that, and equals, and then an open brace. So you can see that the first 3 elements, or the first 3 things that you do in building your set, are all the same. Then what you're going to do is you're going to put in the letter X, and X is going to be your variable. Then there's going to be a vertical line every single time. So whenever you're doing set builder notation, name of the set equals open brace X, or whatever variable they give you, vertical line. And then you're going to write out a description of the set and a closed brace. So what exactly is our set builder notation for this? T equals open brace, X, vertical line. X is a natural number less than 6. So essentially, X is less than 6, but we've put on the qualifier that it has to be a natural number. Because if you think about it, how many numbers are there that are less than 6? There's an infinite amount. So we need to put the qualifier on there to make sure that people understand that it's only 1, 2, 3, 4, and 5. And that's what the phrase natural number does. In this next question, we're looking at building subsets. So it asks, what are all the subsets of the set 3, 4, 5? So what are all the different combinations that we can have of the numbers 3, 4, and 5? Well, the first subset is the set itself. So the first subset of 3, 4, 5 is 3, 4, 5. Then what we're going to do is we're going to almost do like a distributed property here. And we're going to start with 3, and we're going to match up every combination that we can with 3. So our next subset is 3, 4. Then we're going to go 3, 5. Now, have we used every element in combination with 3? At this point, we have. So now what we're going to do is we're going to move on to 4. Since we've already paired 4 and 3, we don't have to do that again. So we're just going to move on to 5. So 4, 5 is going to be our next subset. Now that we've done all of the possible combinations of 3s and all the possible combinations of 2s, we're going to look for single subset elements. So 3, and then 4, and then 5. And then our final subset is going to be an empty set, which is just the 0 with the line slash through it. Empty set is always going to be one of the subsets. The last concept we need to look at in this section is the Venn diagram. Now, Venn diagrams can be any shape, but we normally make them rectangles. And what we're going to do is we're going to put a series of elements within the Venn diagram that's going to represent a universal set, or a set we're going to call U. Now, within that Venn diagram, we're also going to put in a circle. And that circle is going to set off some of the elements so that you'll understand that they have a different commonality than with the other elements of the set. So in this case, what we're going to do is we're going to use the chess pieces, and then within the circle are going to be the chess pieces that can move both forwards and backwards. So the chess pieces that can move forwards and backwards are the king, queen, and rook. Bishops can move diagonally forwards and backwards, but they can't move in a straight line forwards and backwards. Knights do something weird, and pawns can only go forwards. So you can see that bishops, knights, and pawns are within the universal set, but then the kings, queens, and rooks are within the universal set, but they're also in their own set, set A, of chess pieces that can move both forwards and backwards. Now, if we wanted to, we could make the complement of set A. And the complement of set A would be defined as A prime. That's the little line right behind the A prime. It's anything outside of the circle, but within the rectangle. So if we wanted to make a completely new set A to complement A of A prime, we would say A prime is equal to brace, bishop, knight, pawn, close brace. And that would be our complement of the set. Now in problem number 3, we're going to find the complement of a set. So universal set U equals the king, queen, bishop, knight, rook, and pawn, or the chess pieces. And set A is the set of chess pieces that move side to side. What is the complement of set A? Now the complement of set A is still going to be the bishop, the knight, and the pawn. So we would say A prime equals the bishop, knight, and pawn. And then if we wanted to do this in set builder notation, we would say A prime equals an X vertical line. X is the chess pieces that do not move side to side.